Hello everyone and welcome to API Education. In the next 5 minutes we are going to learn a very important concept from data science, that is data structures and algorithms, binary search. Okay, so basically what is binary search? Binary search refers to a way of searching or a special type of algorithm where we search in various types of data structures, and the search must be as fast as lightning. Let me tell you what actually the problem is and how we solve it using binary search. So here is my Python screen. I hope it's visible to you. So let's start. First of all, if I create an array here, suppose a equals simply a list in Python, and then I say a equals input, enter something, and now see, I will just convert this string to a list, and yeah, you got it. I don't need this line even. Yeah. So a is a list here. Whatever I will enter, all the characters will be converted to a list together, and after this I can print the length of a, and also I can print a itself. The problem is, if I want to search for a specific thing like target equals input, enter the target character, index 0. I am specifying this index 0 so that we can get only one single character in the target variable. After this, if we want to search if this character is there, then I will write for I in a, if I equals target, print found at index r, and here I need to convert it to an f string, and r will be added in each iteration. Initially let it be 0, so starting from 0, and I will add it after this thing. So basically, if I is equal to the target, in that case we will print that at index r we found the character. Okay, now what is the problem? Everything seems good right now, but the problem is that if there are huge number of characters in a, suppose there are 40,000 characters, then this particular loop, while checking for each character, while comparing with each character, is going to take a hell lot of time to complete this algorithm. So suppose if it takes 0.1 seconds, this is a comment, so if it takes 0.1 seconds to compare 10 positions, then it is going to take 0.1 multiplied by 1 lakh equals 10,000 seconds to compare 1 lakh elements, and in terms of characters we are talking. So do you afford 10,000 seconds to be given to this algorithm? No, this is the problem, and now we are going to solve it a very interesting way, that is binary search. So let's see what binary search is. For binary search, we will just change the way we search for it. So what is the way? We will divide the whole array in 2 different parts and select a part which is containing our target variable. How? I will first of all create a function binary search, and it needs 2 arguments. One is array and the other one is probably the target. Now we need to sort the array using arr.sort, and also we can print a message that after sorting the array it becomes ARR. Yeah, so after sorting the array we have printed it. Our goal is mainly to find out if the character is there or not, and if it is there we need an array through which we can get it, and at a particular index number. Now dot index function exists here for this purpose, but it will not be useful when there are duplicate elements. Suppose there are multiple spaces in the string. In that case, dot index will not return the desired index number, whatever you wish, if there are duplicate elements. Okay, it will return always only the first occurring of that element. So that's why we are using binary search, which is the perfect solution. Now what we will do is we will cover the whole array from the lower and the upper side. So suppose L is equal to 0 and R is equal to len of array -1. Why -1? Because indexing starts from 0 and len is always 1 plus the total number of characters in the array. That's why I mean the index number in the array. So -1, okay, done. Now we will consider the mid part or the middle element of the array, that is mid, equals L plus R by 2. Okay, and we will use brackets here, L plus R by 2. This is how we get the mid element, and we will keep it in while loop, while, and we can say just true. Yeah, so in every iteration we will say mid equals L plus R by 2, and then if array index mid is equal to the target which we need, in that case, we will return mid. Otherwise, if we can say ARR index mid is greater than the target, since our list was sorted. So if it is greater than the target, now even if there are characters, they are compared using the ASCII characters codes. That's why this is going to work that way. So if array index mid is greater than target, that means the target is on the left of the array. That's why we will say R equals mid -1. And if array index mid is less than the target value, that means the target, oh wait, greater than the target value means the target is on the right, left, okay, and yeah, it's okay. So target, then we will say L equals mid plus 1. So basically we are reducing the size of our whole database or the array in each iteration, and when we get it, we just do it. Okay, now we will say if mid, let's say it here, when we are calculating mid, if mid is less than or equal to 1. Okay, so the index number, the middle element is less than or equal to 1, we can return -1 or false. False is better. Okay, now if mid is less than or equal to 1, that means the middle element is less than or equal to 1, or let's have it less than 1 only, not 0, 1. Okay, and also we will move it here. Yeah, like this. This is perfect. So if mid is not equal to the target and it is less than 1, that is 0, then I will return false. That means the element was not found. Okay, this is going great. So either we will return the mid, or we will return false, or we will just continue executing this loop. So our function is completed. Now it's time to test it. I will say that the array is equal to list input, enter the array. Now I am getting a string and converting it to a list for the binary search option. Then we will say target equals input, enter the target, and again index 0 to get only one single character. Then if, now we will say result equals binary search and then ARR. So ARR is our array and target. Now if it is false, if result equals false, then we are going to say we cannot find the element. Oh, sorry. Cannot find this element. Okay. Else we will print found the element at index, whatever the result is, in the sorted array. And yeah, it's so this is how we search for the element, and this is the binary search algorithm which I have created here. And in this kind of a search, if there are 50,000 elements, after one iteration, and that iteration is not iterating over all the elements, it's only checking if the mid element is greater than or less than the target value. So it's not going to iterate over all the elements even once, and after checking once, it is going to iterate over only the left half part, okay, or the right half part. Okay, so array is divided in half, again divided in half, again in half, and that's why the speed of each iteration increases exponentially, and every iteration takes negligible time because it is not iterating over the elements of the array. Okay, so in this case it's not even going to take 1 second to complete the binary search, and you have reduced the time which was required in that kind of algorithm, which was around 10,000 seconds, to less than a few microseconds. This is the use of binary search. Implement it in your algos and develop something great. So let's try to run this Python file, and especially I am trying to record my computer screen and the specs of my computer are not great enough. That's why it's going to take time to execute the code, but once the code will start executing, it's not going to take time. So let's wait for this thing. Yeah, it says enter the array. I say Ayushman, and then it says enter the target, and I need suppose n there. Then it says after sorting the array, it becomes this, and found the element at index result in the sorted. Oh wait, I must convert it to an f string to see the result actually. Yeah, so I will write an f here and execute the code once again. It found the element in almost negligible time. Let's give a little bigger string this time. So I will give Rajura is the one who is creating this video on API education. Please subscribe to the channel. So this is my string, and then enter the target. I will enter w, small w, and after sorting it becomes this, and before we read this thing, found the element at index 108 in the sorted array. So see how fast binary search is even on my slow laptop. Okay, I hope you liked it. It is complete. Please subscribe to the channel and wait for the next video on DSA. It is really important for your career. Thanks for watching and keep watching.